So this is Beyond Cartesian Mechanicism. This is Beyond Cartesian Mechanicism, Robert Boyle's Mechanical Philosophy by Marina, Paolo Manchetti Robino in Jargonium, which looks like a reasonably new and maybe a popular philosophy of chemistry journal. So it looks like a popular thing. So here we go. Let's see what this is. I mean, it just says 5-minute read, and it just April. It's like forthcoming stuff. All right. So Beyond Cartesian Mechanicism, Robert Boyle's Chemical Philosophy. The modern study of chemistry has its foundations in the alchemy of the Middle Ages, the Renaissance, and the early 17th century. In this period, great progress was made towards a better and more accurate understanding of chemical substances, including their structure, properties, and how they relate to one another. One of the most prominent thinkers to make advances in these areas was the Irish chemist Robert Boyle. Lumpy says, the day I became a homeowner, this is a sign of... Wait, you became a homeowner today? And this is a sign of what? You do not know? Yeah, I mean... On April 15th, 2022. Okay, yeah, so this was, last year, April. I thought this was April 15th, 2023. I was like, forthcoming. So this is actually from last year. So maybe this has just gotten picked up by Phil Papers, because it seems like it's in the forthcoming section right here. Okay, well, so people were thinking about chemistry and philosophy last year too, even while you were not thinking about chemistry, which is probably unusual for you, but you were thinking about houses. Anywho. Okay, in my book, so the author's book, The Chemical Philosophy of Robert Boyle, Mechanicism, Chemical Atoms, and Emergence, I offer an analysis of the contributions made by Boyle and of his chemical philosophy as it related to the dominant Cartesian mechanistic theory of matter. Building on Descartes' mechanistic view, Boyle succeeded in rooting the mechanical philosophy in empirical experimentation while also accounting for the emergent and non-reducible nature of chemical properties. Yeah, that's the old spelling of chemical. I mean, alchemy, of course, is just chemistry, the chemistry in the Arab language is like the chemistry, and so is alchemical with the CYM spelling here. I mean, it's just old spellings. Yeah. I mean, we're really not that far out of alchemy to tell, like, in far as science goes. Like, alchemy is really, really close. One story from the history of chemistry is actually that when they were doing, nuclear research, and they realized that there were a number of atoms, the number of protons in an atom determined which what it was, they were actually discussing, like, if you could add a proton to it, and, like, you could actually change lead into gold. And then they were saying, well, is this the old Philosopher's Stone thing? Like, could you actually be doing alchemy at this point? Is like, this was the old dream to, like, be able to change lead into gold. And they were saying, under no circumstance could you call this transmutation, because they wanted to get away from the old chemistry. But this was still in the minds of the older researchers that were in the physics labs and the chemistry labs that were, doing nuclear research. Like, the people when they were young there were still alchemists around at that point. Lumpy says hides under his rock of shame. There's nothing shameful. I mean, the way people spelled things really didn't get fixed until quite recently, only in the last 150 years, when dictionaries became more prevalent, did the spellings of things become regulated, basically, or set, fixed, or regular. So there's no this is a reasonably recent thing in the history of language where we've sort of fixed the way things are. And this is one of the things about, like, when people say, oh, what are you talking about, like genders and like singulars and plurals? That's really all very recent stuff. Like, all this stuff in the history of like language has changed over lots of stuff in time. Juggling says occultists still practice alchemy as well, particularly hermetics. Yeah, that's the thing. You can still you can still use the ways people thought about stuff back in the day to do things. Like, not everything that they were doing back in the day was wrong. Like it still worked, like, to some degree. Now, did it get all the underlying processes that we understand out of it? No, but so what? It still works. And so if you think in that way and it works for you, it's like you're gonna probably not be as successful as a modern chemist, but you might be somewhat successful. I mean, be as successful as they were, which is somewhat successful back in the day. I mean, and maybe you'll figure something else out too. There's always more research to be done. And so if you are doing alchemy in an area that no one else is studying, maybe you will learn something new. Who knows? Unlikely, but possible. Okay. Yeah, so we're talking about Robert Boyle. Yeah. And he was Irish. I did not realize he was Irish. That's kind of cool. Okay. In doing so, when he was looking at a non-reducible nature of chemical properties, he was also affirming the autonomy of chemistry from more fundamental sciences such as mechanics and its legitimacy as a theoretical and experimental science with its own distinct objects of study and its own distinctive explanatory framework. This is the thing, you can't actually explain chemical stuff in physics. It doesn't work. Like, people want to reduce chemistry to physics. You can't do it yet. Maybe in the future we'll come up with a way to do it, but you can't actually do it. And this is sort of one of the interesting things about chemistry is people think it's like it is a hard science, but the problem is you can't even reduce chemistry to physics. It does not work on the whole. And so it has to have its own explanatory ways of explaining things. Okay, these concerns are still pertinent for contemporary chemistry and philosophy of chemistry. This book advances Boyle's scholarship by going beyond other researchers and providing a detailed look at the parts-whole relation within chemical atoms as conceptualized by Boyle. That is, the book examines in detail the relation between fundamental particles and their mechanistic properties and the properties of complex wholes made of such particles. Okay, so yeah, you can do the physics, but then you can also do what's relevant to chemistry as separate from what the physics is. That's kind of interesting. So maybe this is actually kind of a review of, or she's doing a preface on her book about Robert Boyle. Oh, so this was Boyle. Maybe that's who this is. Isn't this gorgeous? Mr. Robert Boyle, chemist. Before explaining Boyle's critique of his predecessors, the book situates Boyle's thought, in its appropriate historical and philosophical context, that is, into the context of alchemy and the chemical properties of the 16th and 17th centuries. Yeah, this was like, again, there was still alchemy back in the day. Yeah, your wig game is not on par. And someone was joking about this too. Like, in the United States, we're having this thing where like you can't be a drag performer in the United States. It's like you can't even be a historical reenactor because people did this back in the day. It's kind of like, yeah, look at that. That's just fantastic. Before modern chemistry had established itself as a hard science comparable to physics and astronomy, the greatest philosophical and scientific minds of Europe focused their energies on the development and practice of alchemy, which involved the transformation of substances by understanding their physical constitution. The practice of alchemy, however, was grounded in a vitalistic conception of matter that viewed all substances in nature as imbued with a kind of life force that governed their behavior. The chemical philosophy of the Middle Ages and Renaissance was also dominated by the scholastic theory of substantial form, which held that matter is organized and made intelligible by stable by the presence of non-physical forms. This was a view that came under sustained attack from the 17th century mechanical philosophy, and one for which Boyle sought to find a better alternative. The book explores several other ideas, including the alchemical theory of the tria prima, which posits that all substances are composed of salt, sulfur, and mercury, as well as the experiments carried out by the alchemist Daniel Sennert and Jan Baptist van Helmont, which inspired some of Boyle's most important chemical experiments. Yeah, so this is the thing. It's like, if you are changing from this old theory that had like some sort of vitalistic thing going on, that doesn't make your theory wrong in the physical sense. Like, you can postulate a vitalistic thing that you can't really talk about, like a Kantian sense. There's something underneath that's going on, but then if it has all the same like mathematical properties that we attribute to it, then it doesn't really, the vitalistic isn't adding anything to it, but it is also not hurting your theory. So it's like, it doesn't necessarily mean the people who are doing alchemy were wrong about stuff. They may have just got the wrong causal structure, but if you're doing science, who gives a shit? Like, it does not matter if you think that, like, you know, gravity is due to some vital force or the bending of space-time. It's like, for the vast majority of us, it does not matter, like, what the actual causal structure is. It doesn't. I mean, and that was the problem with Newton, is that he was just postulating a force, and Einstein called it spooky action at a distance. But again, Newtonian mechanics got us to the moon. It does most of the things we need, and you might as well just call that a vitalistic force, because it is of that time in some sense. Alright. Cartesian rationalistic mechanicism. In contrast to the alchemical theories that dominated the 16th and 17th centuries, early modern chemical theories tended to embrace the mechanistic view of matter that conceptualized the nature of matter as consisting of fundamental particles which had only the mechanistic properties of shape, size, and motion or rest. The mechanistic philosophy rejected the presence of any type of force in nature and explained the behavior of all material substances solely in terms of the mechanistic properties of fundamental particles. There were several iterations of the mechanistic philosophy, one of which was the Cartesian corpuscularian view, and another of which was the modern atomistic theory. Cartesianism differed from atomism in that, although atomists believed fundamental particles to be absolutely simple and indivisible, Descartes argued that all material particles, no matter how small, were always divisible, at least in theory. Boyle tended to agree with the corpuscular view, but also with Pierre Gassendi's molecular theory that corpuscles could form structured combinations with varying degrees of complexity. Okay, so all of a sudden, we've got these like infinitely divisible like atoms, which of course we kind of now think is, you know, you can kind of divide them up quite a bit into subatomic particles, but then this corpuscular theory had also, you could, you know, make structures out of them that were very complicated. So if this wasn't in the early atomistic theory, see, it looked like the corpuscular theory had something going for it. That's kind of cool. Although Boyle endorsed the mechanical philosophy, he identified a tension between the Cartesian mechanistic worldview and observations from real-world chemical, pneumatic, and hydrostatic experiments. For example, Descartes' strict mechanistic philosophy could not account for the causal nature of chemical properties or why these properties changed when substances were chemically analyzed or synthesized. Descartes' view was, therefore, inconsistent with the results yielded by scientific experimentation. This book explains how Boyle sought to resolve these conflicts while continuing to embrace both the mechanistic view of fundamental matter and the reality and causal efficiency of chemical properties. However, before discussing Boyle's deeply complex chemical philosophy, the book first outlines how he abandoned the dominant scholastic theory of substantial form and instead advanced the idea that chemical substances originate in and find stability from the internal structure of their complex corpuscular concretions, which give a substance its various chemical and sensible properties. Yeah, you see this concretions right here? That means something has an internal structure, I think, is what's going on. And so the internal structure is what is really giving you your properties there, and not some sort of vitalistic force. So it's building what the work of what the vitalistic force used to do, and this scholastic thing, the substantial form, into the structure of the physical or chemical properties. So, okay, according to Boyle, different corpuscular structures account for different substances and different properties, and he develops a theory that incorporates the hierarchies that exist within chemical structures and compositions. Thus, he is one of the first practicing chemists to advocate for the idea of microstructure, although he did not use this modern terminology, but he also uses experimental findings to lend empirical support to the theory of microstructural composition. Yeah, so this is like good stuff then. So it's like he did not understand what it was, but he had this sort of complex corpuscular concretions. You know, this was the terminology of the day. And like Lumpy mentioned, like the weird spelling of chemical, but so what? We have corpuscular concretions now. History of science. Always so much fun. Okay, Boyle's view of chemical properties and the relation between parts and wholes. In addition to discussing Boyle's conception of complex microstructural composition, which in some ways anticipated the discovery of molecular structure in the 19th century, the book also analyzes Boyle's ideas on the fundamental nature of chemical properties, arguing that he considered such properties as being dispositional, relational, or emergent. Since the emergent properties of a substance cannot be simplistically reduced to the mechanistic properties of its Since the emergent properties of a substance cannot be simplistically reduced to the mechanistic properties of its constituent corpuscles, it follows that such properties cannot be fully explained or understood through a reductivist mechanistic conception of fundamental matter. Boyle's view supports the idea that chemical theories are not reducible to purely physical theories, and that chemistry as a science must retain its scientific autonomy from physics. Yeah, thank you, Juggling. Saying corpuscle is not a normal word that I get to say a lot. This was a very important conclusion for Boyle, and one that set him apart from Descartes and his followers, according to whom chemistry could never be considered a genuine and autonomous science. Yeah, and so this is actually a really interesting thing, that Boyle said you can't actually reduce chemistry to physics, which was a minority view, and now I think people have moved away from it. But I think it was actually, people thought we were going to be reductionist because, the positivistic theories of the 20th century said, look, we're going to get more and more knowledge, and eventually we'll have this grand unification theory and we'll have everything figured out. I think we've moved slightly away from that now, but again, that's a sociological question. I don't know. Okay. Mereology, as the formal study of the relationship between parts and wholes, dates back to the philosophy of Aristotle. Because chemistry as a science essentially involves the study of the relationship between parts and wholes, it easily lends itself to the application of mereological analyses. By applying a mereological analysis to Boyle's conception of structured chemical wholes, this book makes a truly original contribution to Boyle's studies. It concludes that such an analysis supports the argument that Boyle viewed chemical properties as dispositional, relational, and emergent. The author argues that Boyle regards corpuscles as the parts and their aggregate structure as compositions as the whole. It is not the parts but the whole that accounts for the properties of chemical substances. These ideas are explored by referencing mereological theories that were developed in the Middle Ages but that were still relevant during the time of Boyle, and with which early modern philosophers and scientists would have been familiar. So this is cool. They're shouting out some of the philosophy of science and mereology from the Middle Ages, saying it was actually helpful to the development of chemistry as a science. Lumpy Dragon Potato says, well, physics and chemistry are merging, but it's a budding field. At my university, a researcher used STM to elucidate an old organic chemistry mechanism by going like atom per atom. I don't know what a atom per atom is, but okay, cool, but people are actually doing it. Yeah. What is this? Yeah. Atom per atom. Sorry, yeah. So that's interesting that someone is actually doing it, but yeah, I'm not surprised if it is a budding field. How would you do it? Even in the simplest cases, I know it's extremely difficult. And this is my knowledge from years ago when I was in school, but these are not the sort of things that change very quickly. You just can't figure out how to do all the mathematics of complex things at a very small scale. We just don't know what's going on. Okay. By both situating Boyle's ideas in their appropriate historical and philosophical context and providing a deep conceptual analysis of those ideas, the author has cemented the importance of Robert Boyle in the history of chemical philosophy. Lumpy says, one project took years. These instruments are big and fragile. Yeah, this is the thing. People, you might be able to do it sometimes, and it's going to be hard and it's going to take time. And kudos to that researcher for pulling it off, even in probably one of the easier cases that they could come up with. That doesn't even mean just because it's easier, it did not make it easy. I'm sure it was really hard. Okay. The book shows how Boyle moved past the scholastic theory of substantial forms and the theories that dominated Renaissance alchemy, and how he was able to build upon the Cartesian mechanistic theory of philosophy while avoiding some of its most problematic implications for chemistry. By supporting his chemical philosophy with empirical observations of his own experimental work, Boyle took chemical philosophy to the next level and anticipated many of the issues that are currently being debated in the philosophy of chemistry. This underlines not only Boyle's most important contributions to early modern chemical philosophy, but also underlines the enduring relevance of his ideas. Cool. Yeah, like the history of chemistry and the philosophy of chemistry is actually really interesting stuff, and it's one of these like sort of niche areas within the philosophy of science, because frankly, if you're going to be in the philosophy of science, you're usually going to be in general philosophy of science. You're going to be doing philosophy of physics, maybe philosophy of biology, but philosophy of chemistry is, not the like hot field. There's just less work there. So there's like cool stuff that like these people have got together, and they're writing stuff on philosophy of chemistry. Yeah, I'm trying to remember. Like, I think Boyle, his chief. I feel like I'm screwing this up, but the thing was, they didn't really understand where like the energy was going in chemical reactions, and so he actually postulated a conservation of energy principle. So the energy in had to be the energy out. So like if you had like high if like you were losing energy over the course of your experiment, that means that the result had to be in a lower energy state because it was releasing the energy to like the system. And so like there was a conservation principle there which never was there before, but this made it sort of like a mathematically a mathematical formula: A plus B equals C, and it's like the equals really means that the stuff that was on the left was the same stuff on the right. Now, of course, the problem is it's never exactly accurate, and so they had to be like plus a little loss to entropy. But the idea that the stuff that was lost was insignificant and otherwise should be mathematically equivalent, this was very new. And so this is why there was a lot of animism and stuff, because people didn't understand where the the power, the energy that was in the chemical in the molecules, where it was going and how it was being transferred around. So you got explosive things, you've got things that absorb energy, so it's like, where is all that going?